Hey, welcome back. Day 2, fractions, gotta love them. I always say to my students, fractions are your friends. And you know what they say to me? Ben, you're crazy. Okay, I understand. Fractions are like this point where things just went off the rails for a lot of students. All the way back in elementary school, middle school, high school, it's like, fractions, I don't know anything about anything. Well, I'm gonna try to break it down for you today. And I hope that we can make some progress with your feelings about fractions. Number one, I really want to try to get at some of the understanding pieces about, why fraction operations are the way they are. In general, what's confusing about fractions is that there are these sets of steps that you have to take for each operation, So for addition, it looks like this, and multiplication, it's like this, and division, we got this other rule. Who knows why that is the way it is? It's just, that's it, man. So, learn it and love it. Well, I'm going to try to change that a little bit by really talking about what the sense is behind those things, because really, even though some of them are difficult, like understanding why division works the way it does, or why we treat it the way we do, is challenging, I think it's worth you knowing that you can understand it. Okay? So let's start with addition and subtraction because they go together. In general, this is true. If we have a little grid here, I've got addition and subtraction, and then over here I've got multiplication and division. And it's worth grouping things together because addition and subtraction share something. That is this really important property. What the? Where'd my markers go? Pardon me for a second while I get out a beautiful red marker. They share something, which is that you only add or subtract like things. Okay? So for instance, if I have 3 boys plus 3 cats, how do I add those things together? Well, I can't really add those things together unless I'm talking about 6, something that describes both a boy and a cat. So creatures, it's kind of hard to lump them together. If I change this to dogs and ask you how much is 3 dogs and 3 cats, we have words that more easily fit in there, like 6 pets or 6 animals. And the key is, in order to add them together, I have to be talking about like things, okay? That's something that binds addition and subtraction no matter what we're talking about. Whole numbers, negative numbers, fractions, decimals. But multiplication and division, they don't have to be like things. You don't need like things. And in fraction land, this will pop up in a very interesting way as we start talking about things like halves and fourths and thirds. Okay? So, start with addition and subtraction. Bada boom, bada bing. So that story about the cats and the dogs is really at the heart of all of this, right? If I want to add a third, my brown marker is dead. If I want to add a third and a half, in order to add them together, I need to be talking about the same kind of thing. Now, I'm just going to write the words here because this is important. I have 1/3 and I have 1/2. Clearly, I'm talking about different things. If I use a circle as a whole, a third is like this part, and a half is like this part. So if I add those two together, then I'm going to have something that looks like this. Okay, like a Pac-Man upside down. So I don't have a whole yet, but I'm getting pretty close to a whole. Okay? And so the idea here is, can I put these together? Yes, I can, but I need to make them the same kind of thing. Now mathematically, it works like this. If I scale this up by 3 and I scale this up by 2, then I end up with something that is the same in the denominator, 1/6. Now, we just did a whole bunch of stuff that kind of blows your mind here. let's do it in picture land, and then I'll get back to the math part of it. What I'm going to do is I'm going to break this into 2 pieces, and I'm going to break this into 3 pieces, and then these pieces are all the same size, so I can count those up. And what happens then is that I've got 1, 2, 3, 4, 5 pieces, and these pieces are things that we call sixths. Okay? And they're sixths because if I complete that circle, there's that missing sixth. I've got a circle divided in 6 pieces. Or we can think of it as a third divided into 2 parts is a sixth, and the third half divided into 3 parts is a sixth. Okay? So that's what I end up with, 5/6. 5/6 is the answer to this question. Now, let's talk about this 2/2 times 1/3, 1/2 times 3/3. Okay? So first of all, notice that this is 1. And this is 1. And that's critical because when I multiply, I can change a fraction, I can change the way it looks, but not change what it actually is worth if I multiply it by something that's equal to 1. 2 over 2, 3 over 3, 4 over 4, 5 over 5, 6 over 6. You get the idea. So as long as I multiply the top and the bottom by the same thing, I'm going to have a new looking fraction that's actually equal to the same amount. Check it out. 2 times 1 is 2, 2 times 3 is 6, 2/6 is the same as 1/3. Okay? There's a couple ways we can prove that. If you want to take your calculator, now would be a good time to take 2 divided by 6, see what you get, and take 1 divided by 3 and see what you get. Try it out. Okay, so we've got 2/6, we've got 3/6, and the answer is 5/6, just like we did with the pictures. The key here, once we have a common denominator, is because I'm talking about the same kind of thing, I'm ready to just add the numerator. Those words, numerator and denominator, may sound pretty fancy, and I think they're actually kind of important in terms of what fractions are all about. So this is the counting, the one that tells us how much, right? And this is the denominator, which is actually just the name and how big each piece is. And I really like to use circles, okay? So if I'm talking about a tenth, in my mind, every time I'm saying the word tenth, I do a real quick divide this up into 10 pieces, so I get something that looks like that. I don't know if that's exactly a tenth, but that's kind of like what a tenth is, right? And the third, same thing, I've got a circle, I'm imagining it divided into 3 pieces. That's the old peace sign, so something like that is a third. Okay, so that's what I'm imagining. If I want to add a tenth to a third, I'm adding this little piece of the circle to a much bigger piece of the circle. In order to accomplish that, I need to change the denominators because I need to make them into the same kind of thing in order to add them. Okay? Let's make it subtraction just for fun. So that way we've done subtraction and addition. A tenth minus a third. In this case, right, we can see that I've actually got something interesting going on, which is that I've got a small part and I'm taking away a larger part. And we know from our work yesterday that when that happens, so for example, if I say what's 2 minus 5, because 2 is a smaller part than 5, this answer is going to be negative. So in a similar way, I already know this answer is going to be negative because I'm asking to take away more than what I have, right? I can't get a third out of a tenth unless I borrow some, that negative idea, owing, right? But the mechanics are the same. I need to scale this up, I need to scale this up. What number do 10 and 3 both divide into? We can always, always, always multiply by the other denominator. That's the easiest way to get a common denominator. I'll show you a problem here in a minute where that isn't necessarily the best way to do it, but this is a good way to start. So if I scale this up by 10, I scale this up by 3. Remember, that's like dividing my tenth into 3 parts and my third into 10 parts. Then I get 30ths. 3 30ths, I need to take away 10 30ths. 30th is what I'm talking about. 3 minus 10 is -7. So that's my answer, -7/30ths. Okay? So that's the basic idea of fraction subtraction. And now I think what's important is for you to get some experience doing that. And I've also got a video that shows you an example of that situation I was talking about where you actually don't need to multiply all the way up by the other denominator. But that's a good start, right? If you can understand that piece of it, that we need to have a common denominator, and then once we get the common denominator, it's just taking the numerators and adding or subtracting, whatever they tell us to do. All right, hit it. Let's see what you can do.